This is issue number 40 for the Kaiju Engine, where we are going to be creating a vertex layout here. So, in the last issue we set up for shaders, we had just these three verts here lined up and a linear array, and then we loaded them up to GL directly into this index 0 of the layout. So vertices are going to we're going to be adding a few things to our vertex, so we can better use other information like normals and UVs and tangents and weights for 3D animation and that sort of stuff. So instead of rendering, I'm going to create a vertex.go, and we're not going to really need much in here because it's just defining what our vertex is. So we'll start off with a position, and we don't need to use a vector3 float here, or sorry, an array of floats. Here we can just use our matrix dot vec3 because that's exactly what it is. So this order is just my own order. There's no rhyme or reason. So this one is going to be a normal, a tangent, then we're going to do a UV, and you can have two sets of UVs, and we may do that later, UV0, UV1, but I'm just going to leave it as UV. In fact, just to prepare for potentially doing that, we'll do UV0. Color, we'll do vec4 there, and we should probably make a color structure to do replace with color struct later. So we can, which is basically just going to be a vec4. But we'll use vec4 for now. We'll have joint IDs, which is going to be matrix.vec4i, so an integer vec4, which we haven't made yet. And then joint weights is going to be a matrix vec4, not mat4, vec4. These are going to be the weights against those. And then we're going to add in a morph target matrix.vec3. This will help with deformation, animation type of stuff. So let's go create this vec4i. I suppose we can make the color too, you know. We're making an engine here. No need to rush things. So we'll just make vec4i.go package. And we're not going to fill this out with too much stuff. We're just going to say type vec4i struct. And these are just going to be regular int32s. And we are going to use the explicit sized type here whenever we're communicating with the GPU or any other outside thing. We want to be explicit with our sizes, and also especially if we're going to be serializing. It makes serialization a lot nicer. So we've done that one. And color, maybe we can put color in rendering to color, or we can make a package for color. There's not a whole lot. I mean, it would just be a color package with a color in it. I don't like that because there isn't going to be a whole lot to it. We can also place color inside of our matrix code because it is a vec4. Maybe that's fine enough for now. We can move it later. Color.go. Package, matrix. I was going to type rendering. Type color, struct. Now, we could also make color into a vec4. That way it can have all the vec4iness that a vec4 does, which might be kind of neat because then inside of then we can just set some helpers in here, so func r, and we can just return these sorts of things. I don't know why I put these. I can just put them all in single lines. They're not doing much of anything. And then these are functions. We don't need to do a function. Say vx. Oh, I think it's capital VX. VY, VZ, VW. That'll be our RGBA. And then we have a couple of functions in Vec4 that are fun. We have this guy, and we can do it as RGB as well here. But and then we'll have to make one of those. I'll just do this guy here, essentially RGBA. Cool. I can also make this return XYZW. I'm gonna do C. C color. There we go. Cool. And there are a couple of color functions I guess I can write in here for mixing colors and that sort of stuff. Okay, also these need to be float type. And this is mad because it has no fielder method of XYZW. Okay. Well, we can just I don't really want to cast it, so we'll just paste this back in. No need to do any fancy casting. We are going to pull over the P for the pointer ones that allow us to do some fancy pointer stuff. Call this C. Oops, color goes here. And change this to C. Okay. Cool. Let's make a helper function, func new color, return. And our default color, we need to pass in RGBA float. Thank you. And I have a whole bunch of predefined colors I've previously made in my last Go engine. So I'm just going to copy those over because there's a lot of them. So if you're interested, just check out this file in the repository and you'll see all the different colors that we've got set up. So one of the functions I really want to make here is func color mix, LHS, RHS, left hand side, right hand side, amount float color. This will return color with a LHS.R plus RHS.R minus LHS.R times amount. And we'll just do all the rest. That'll give us our color mixing. So now that we have those, I also want to create a toString method for printing out stuff. Func C color toString. I guess this would just be the same as the float toString. So since we already have that, I'm going to do color from hex string because this is special. Str string. Essentially, we can take in like a hex code and turn it into a color. So var, we'll do C. Well, the hex string is going to be in color 8, the 8-bit format. So maybe we should create we have a color, and then we can have a color 8 where there's a uint 8 for each of the slots. Type color 8, which is going to be a struct. We can't do it with vec4i because it's going to be a uint 8 for each of these. And now what we can do first is create a func color 8 from hex string. RGBA is equal to color 8. And then we'll just start everything off at 255 on all of those. So we want to, whoops, I don't know what it was doing there. We want to trim, if there is a pound in front of it, we do want to trim that. Hash, whatever you want to call it. And we just say if the length of the string is equal to 8, then we're going to do format.scan or scanf, and we're going to scan str. Let me see if this is the correct format. 02x. Yeah, that's fine. Then we do else if the length is equal to 6. Pretty sure it can guess where I'm going from here. Else if it's 4. I don't know if 4 is common. Let's do 3. This is a big goofy way to do it. I don't know. I don't have the mental fortitude to mess with that right now. Essentially, this is what I want to do. I want to convert it into a regular formatted string, and essentially do this first one here. Hold on. Oh, it would be RGB, and then A will be 255, so that's correct. It'll just stay the same. Else RGBA is equal to color 8 from color is what we're gonna have a way to pull a color 8 from color. Color magenta. This is usually the color used for an error, right? Error equals format invalid hex color string for us. And return new color 8, and then those guys. So here we're going to return a color 8 and error. Although I don't know why don't I just return our GBA. Okay, so we're going to get a color 8 from color, and also a new color 8 in here. This is going to be a uint 8 color 8, and then color 8. And now we want the func color 8 from color. It's pretty straightforward. Just multiply by 255, cast to an int. And then we also want func color from color 8, which also should be pretty straightforward for it to guess. Okay, so now we can finish up our color from hex string. We can say color 8 error is equal to color 8 from hex string return color from color 8 and the error. So here we pass in color and error, or return. Okay, cool. And this is going to complain about the capital. Yeah. Okay, cool. So now we have a color. I'm not going to, there's more stuff we can do in here, but I'm going to leave it at this point so we can get back to our vertex code here and then change this to matrix color. Sweet. So when we start having a vertex, one function I like to make for later is a vertex face normal. Verts 3 vertex and return a matrix dot vec3, and we'll say v0 is equal to verts 0 dot position, v1 v2 e0 is equal to v1 dot subtract, v0 e1 should be subtract v2, and then we can say c is equal to the cross product is matrix.vec3 cross. We're going to cross E1 with E0 and return the normal. Geez, I was guessing all wrong there, left and right. So Now that we have our vertex, we want to come back into how we did our main here, how we were laying up how we were binding this data. And we're going to want to do that as part of the OpenGL renderer. So the renderer GL should create the VAO and VBO um, out of it. So which means the renderer is going to need a way to create that mesh identity. So we're going to come over here and say create mesh. And this is going to take in a mesh, which we don't have yet, the verts, which is just a slice of vertex. Oops, vertex. And then we need the indices, which is a slice of uint32. And so now we should create a stub for the mesh. We're not going to do a whole lot with it. This one is just about getting the vertices up and going. Rendering. Oops. Rendering. Type mesh struct. So just to keep it simple, we'll create a mesh ID. And this will be similar to what we did with the shader, having a render ID. I guess this should be shader ID. I rename this to shader ID. And so type mesh ID interface. And we're actually going to create what this mesh ID is inside of here for now. Let's do a type mesh, or we say GL mesh ID, or mesh ID GL struct. And this is going to have a VAO GL handle, VBO GL handle, EBO for our instancing, and we're likely going to need to have the count of indices in here, but just for simplicity, we'll have it like this for now. And I suppose we are going to need a mesh GL and a mesh VK so that we can construct this object here. Or I guess that's the whole point of what we're doing right now instead of the renderer GL. So let's go down to our, what do we have? I don't even think I've created it yet. So we need this create mesh function. Func r GL renderer create mesh. And so this is the mesh we're going to be passing in. So mesh.mesh ID is going to be equal to mesh ID GL. We're going to set up our stride and save that size of verts 0. Then we're going to do the index, or the vert size is equal to stride times the length of mesh dot pending verts. Why do I have pending verts? I think it would just be the length of verts. I think we can just do verts here. Pending verts is for when we get into more complex mesh stuff. We're just trying to keep it simple for now and build out later. So next is going to be the index size. Index size is equal to the int unsafe dot size of uint32 times the length of indices. So we're going to grab the index count. We're going to need it for when we're doing the instancing of elements. So let's go up to the top here and we'll have a index count. For now, we will have it as an int32 because we'll be passing this along to GL, so it should have an explicit size. So we'll do mesh.mesh ID. is render. So let's take this and call this ID is equal to this. This is equal to ID, and we'll paste this at the bottom. Okay, so we can say ID dot index count is equal to the length of the indices. So now we say ID dot VAO is equal to, we can probably just cut this from the main. VAO, yeah, we can have these VAO. We're not going to be using this method. We're using this method. VAO, VBO. And then we're also going to be generating one buffer for EBO. Now later on, when we get into the WebAssembly part of this, these functions don't exist, I don't believe. So we may have to wrap these up. We're going to have a wrapper for the different GLs, but for now we'll just inline it out so we know what we're doing ahead of time. So now we're going to grab that bind vertex array, pass that in. We may need to serialize these, the vert and the indices. We'll see, but for now I'll just leave a gap. We'll do GL bind buffer. It is going to be an array buffer of VBO. And then we're going to do buffer data, array buffer, and we're going to want this to probably be, this is where the bytes stuff is going to come in. Let's see, where do we do the buffer data here? We just pass in the verts, which is an array of float 32. We are probably going to do something else with that. Let's see that function. Yeah, because we could bind other kinds of data here. So I'm just seeing how this is dealing with it. Yeah, so it's just getting the address of that and passing it along. So we're likely going to just need to pass in the data as an unsafe pointer. And the second argument is going to be the length. So we'll need the size of that structure to also be passed in. So we're probably going to change this out to pass in a pointer and then the size of this data. So it's more C-like in that case. So let's give that a go. We're going to do data unsafe dot pointer, and then instead of a float 32 here, we're going to do the data size is going to be int. We should be doing more than 4 billion or 4 gigabytes. If we do, we can change that up. Cool. Or uint, I guess. So we'll take the data size, plop it in here, take the data, just plop it in here. And then we're going to need to change this to be the address of this verts unsafe.pointer. And then the unsafe.size of verts. And we'll want to make this into a uint. I think that's what I made the second argument. Yeah, uint. Okay. Oh, I'm in the wrong place here. Get back over here. Okay, paste those two. So the verts and then the size of verts. So now we're going to do gl.bind buffer, gl.element array buffer, and then EBO. So we need to make this constant. I don't trust what it's going to pop up, but then we can go verify on glad.h. GL element array buffer. It figured it out. Okay. So now that we've bound that, the next thing we need to do is gl.buffer data, and we need to do gl element array buffer indices, indices. And this one is the same thing, unsafe dot pointer indices, size of, and then static draw on that. Well, now we'll do p offset is equal to 0. This is the offset that we're going to do going through the, this needs to be a address of 0 on both of these. So what we're going to be doing here is oh wait, this isn't going to be right. Is this going to be right? What is the size of array returned to you, or slice? It's probably not going to be right. Glad I caught that. We're going to be doing the size of verts 0 times the length of verts. I guess I could put this outside. Oh, wait, no, this is an int. Which means this has to be an int. Oh my gosh. Whew, that's a little annoying. I'm just going to make that a variable up here. So we'll say verts size is equal to this madness. And we're going to do the same thing for indices. X indices index size, just because it's the same length. Yeah, word-wise, vert, verts and index, not actually the same length data-wise. Index size, we already have an index size. Oh, I already have it. Puts an int. Make this a uint, and then change this to indices 0. Cool. I'll just put this up here. Oh, I have a vert size. These are going to be the same thing too. Unsafe verts 0 times the length. So that's the stride and the length. Cool. So I was wasting my time. Stride, and this is going to be uint stride times uint length, just in case. This needs to be uint length. Cool. So now I can just use vert size and index size. Now we can begin. So this is the vertex positions. So gl.vertex attribute pointer 03 gl.float false stride p offset. Okay, doesn't like stride. It wants stride to be an int32, so we'll change this to int32. It wants the p offset to be an, oh, what is it supposed to be? Unsafe pointer. Hold on, let me see that. Unsafe pointer. Yes, I know it's a pointer in C, but it's usually just like 0, 4, whatever. So I'm just gonna not pass this. I'm gonna pass this as a what I expect it to be. I'll just say int32, I guess, and then we will unsafe pointer that offset. This is gonna be a uint ptr cast. There we go. So we don't have to do it everywhere else. That means this has to be an int32. Again, we want to use the sized integers when communicating with the GPU here, just to not make any mistakes. GL enable vertex attribute array 0. And then p offset plus equals int32 unsafe dot size of vector 3, so position. Next is going to be the normals, and I think that this thing is going to start guessing it correctly from here, so I'm just going to let it do its thing. Texture coordinates UVs 0. Okay, I don't know why I guessed that wrong. Must not have the context for the file anymore. Tangent, joints, and I'll check the order of this. after to make sure that we're all good. Morph targets. Okay, and we don't need any more after that. So we've got position, normals, texture coordinates, tangents. Hold on, I think that's in the wrong order. Let's go to our vertex. Position, normal, tangent, texture coordinates. Okay. And we'll need to change this to 2 and this to 3. This to 3, this to 2. Okay, so normals, tangents. Tangents have their vector 3. I think they're supposed to be vector 4. So let's change that. Tangent is a vector 4. So where were we? Tangent 4. Okay, texture coordinates. Then we want to look at the color and then weights. Is it weights? Joint IDs. Yeah, it's joint IDs, weights, tangent. So joint IDs, weights, and the target, morph target, not tangent. Cool. 6, 4, 5, 4, 4, 4, 3, 2. Okay. So we need to add this ent in here, just like we have float. See if it guesses it correctly again. Yep, GL ent. Okay. So that sets up all of that binding. And now we want to unbind. Unbind. gl.unbind. Oh, I don't think we have this function. Unbind buffer. gl.array buffer. gl.unbind vertex array. So let's create these two guys. Down here. Func. Okay, and it's 0 here because you would pass in 0 null or whatever inside of C, so there's no point in doing. There actually isn't an unbind in C, and there's no unbind here, so these are just helper functions to call the bind functions. And we can do it directly through C, and we don't have to use the already made wrapper functions just to make it slightly faster. I don't know. It's not that much faster. So with that, that takes care of our primary, this portion. So all of this is now set up for a triangle. Now we want to try to create the triangle again, except this time as a mesh, and see if it works correctly. So host.window renderer.create mesh, and we need to make a actually need to make a mesh, which will have like a mesh cache at some point. But I'm just going to create a mesh rendering.mesh, some blank mesh here. Pass in the address of this mesh. Now we need the verts and the indices. So our indices is just going to be 0, 1, 2. And we are going to take these as our verts. So verts equals array of rendering.vertex. The position. Oh, whoops. So our first one, the position is going to be this guy. Matrix.vec3. And then we can copy, paste, paste. Take in these guys for our second one, this guy for our third one. And we don't really need to set anything else, just because we're not texturing, we're not doing anything else. So I'm just going to leave them all blank, but I may make the color into matrix.color white. Or what color do we have it as? Orange? I think we had it like orange. Color. Let's do blue just so it's. Oh, wait, the background is blue. Color green. Cool. I like to choose a different color when doing a new test just because it makes me sane and feel like I've actually changed something. So there we've got our verts, we've got these indices, indices equals that. Now we don't need to do um, these guys here. I mean, technically we're going to be doing them in the renderer, and we're going to pass in all of our meshes to be rendered and that sort of thing, all of our shaders. So I guess I could leave them here and just do mesh ID and then cast it. This isn't real world, so mesh idgl dot VAO. This isn't real world, so I don't care that it's goofy. And we're not doing any rendering specific stuff right now, so I'm not going to set up draw elements or anything like that. What I will do is I will make sure that color is working inside of the shader. So where did I put that? Content. Here we're taking in our position, and then we can actually go to, oops, that's not it, Vertex. Let's just copy all this, paste it. We can just use the same naming. Why not? So the position, we're going to set up our cameras and all those matrices in a bit. So next we have normal. Next we have tangent. It's a vec 4. Next we have UVs. Even though we're not using these, I'm just going to put them out here just to exist. This is vec 2. Next we have, where are my UVs? Color, joint IDs, joint weights, morph target. Okay, so we got our vector 3, vector 4, vector 2, vector 4. Joint IDs is vec 4i. Wait, what am I doing? Vec 4 is fine. It's just integers. And then we have vec 4 and then a vec 3. Okay. And then change all these. 1, 2, 3, 4, 5, 6, 7. They should match the binding that we did previously. And we also want to forward to a out to for the color, so we can use that. So we're going to say out vec 4 frag color, and we can say frag color is equal to color. And come over here, and we can put in our in vec 4 frag color, and then just use that. Okay. Now to compile and see what we broke. Apparently we didn't break anything. And there's our green triangle now using our custom vertex and all that fancy stuff. So sweet. I think that's all we really need on this one. We're gonna have other issues for actually rendering out meshes, filling out the mesh, materials, all the other stuff. So we're going to leave it here. When we go into the rendering stuff, we'll then do draw elements for instancing. Once we get all this basic OpenGL stuff completely done and it's rendering and doing things, we'll then move on to Vulkan, and that's going to take a lot of time as well. It's very heavy-handed in setting up everything yourself, but luckily I've done this multiple times before now in multiple languages, so hopefully we can get through it as fast as possible, at least the Vulkan stuff. So that's it for this, and I'll see you in the next one. Thanks.